So here is an oscilloscope, and in fact this is the oscilloscope depicted in your drawing. And what we're going to do now is we're going to go through knob by knob, switch by switch, button by button, and I'm going to tell you what each knob, button, and switch does on the oscilloscope. So beginning in the upper left hand corner here, you see the knob that says intensity. If you look at it in your drawing, it says intensity. The intensity knob is used to adjust the brightness of the trace. Notice how the trace gets brighter and dimmer as I adjust the intensity. To the right of the intensity knob is the focus knob, and that knob is used to get a nice sharp image. We want to have the trace as sharp as possible to get an accurate measurement. To the right of the focus knob is the trigger level knob. And what that does is that tells the oscilloscope where to start the trace. Notice that right now the trace is beginning about the middle of the screen on the positive slope. Anytime it's rising, it's positive. If it's falling, it's negative. So it's beginning on the positive slope. I can adjust the trigger level so that it's more positive or more negative, right? And the thing is, I have to stay within the limits of the trace, because once I go beyond the limits of the trace, the oscilloscope has nothing to reference and doesn't know where to start it. And so we get this right here. So we'll start it right back here in about the center. Now this knob also will pull out, and if you look at your drawing, it says pull, and then it has the negative sign in parentheses and says slope. So by pulling this knob out, it inverts the waveform so that it begins on the falling slope, which is the negative slope. All right. To the right of the trigger level knob is the coupling switch. Coupling switch has 4 positions: auto, normal, TVV, and TVH. All right. TVV and TVH have to do with the composite video signals, vertical and horizontal. We will not be using that at all. When we have this set in normal, well actually when it's set in auto, the oscilloscope will trigger automatically, whether there's a signal for it to trigger from or not. In normal, it will trigger only when there is a signal for it to trigger from. So we'll keep that at auto. The source switch, just to the right of the coupling switch, which is right here, tells us where the trigger signal is coming from. For example, it's set right now to channel 1. We can get the trigger signal from channel 2. We can set it to line, which is the line voltage or the line signal that comes in from the plug in the back. Or we can apply an external trigger source altogether using this connector right down here. We would actually have a separate signal imported into the oscilloscope used to trigger whatever signals are being applied. To the right of the source switch is the hold off knob. Now the thing about the hold off knob is when I adjust it, it really doesn't do anything. It may make the trace a little bit brighter, but that's incidental. The primary use for the hold off knob is if I have a series of pulses. Usually I'll have a series of pulses from a digital signal, and then I'd have a space in between, then I'd have another series of pulses and the space in between. The oscilloscope doesn't really like that space in between and will produce what we call a ghost image to try and fill it in. And so to eliminate that, I can adjust the hold off knob and it will allow that space to be seen properly. Then you'll notice that this knob also has a pull out feature. It says pull chop. Now what this does is, it doesn't make such a big deal again as we're using the oscilloscope right now. But when I'm using the oscilloscope and trying to analyze 2 signals at particularly lower frequencies, it will allow the oscilloscope to alternate between the 2 signals so that Channel 1 is seen for a moment, then channel 2, and it just allows us to alternate between the two signals at lower frequencies. To the right of the hold-off knob is the XY button. The XY button is a push button. In other words, I push the button to engage this feature, and I push the button again to disengage this feature. When engaged, this actually separates the signal and uses the full XY axis so that we can make adjustments on both planes, on both the X and the Y axis. This allows me to take a look at two waveforms, for example, and I can see if the two waveforms are in phase, of the same frequency, of the same amplitude, things like that. I can also use this feature to determine the length of a cable, the resistance of a cable, and if the cable has any damage somewhere down the length of the cable. To the right of the XY button is the horizontal position knob, and what that does is it allows me to position the trace side to side. So I can move the trace horizontally so that I can position it wherever I want it on the screen. Again, you'll notice this knob has a pull function, and it says that when I pull this out, it's 10 times magnification. Now what it's doing is it's magnifying 10 times side to side across the screen, so that when I go to take a period measurement of the waveform, it would actually be 10 times less in frequency. It'd be 10 times more time, which would give me 10 times less the frequency. In the middle row, of course, the power button is used to turn the oscilloscope on-off. That's our basic control. To the right of the on-off button is the vertical position knob for channel 1. You'll notice everything in this section right here is all associated with channel 1. There are three, this knob, and this switch are all associated with channel 1. Now, what this does is this allows me to position the trace vertically so that I can move it up or down on the screen wherever I want it or need it. Also, this knob has a pull function. I would use that when using an external trigger. To the right of the vertical position knob for channel 1 is the vertical position knob for channel 2. It does exactly the same thing, but notice when I adjust the vertical position knob for channel 2, nothing happens. And the reason for that is we're not looking at channel 2 right now. All we see is what's on channel 1. To the right of the vertical position knob for channel 2, oh, by the way, the vertical position knob for channel 2 also has a pull feature. We would use that when using the XY function. The variable sweep knob, which is this knob right here, is used for calibration. Okay, so for example, the signal that's coming in here has a specific frequency that's set by its source. And what I can do is, if I know that specific frequency, I can use the variable sweep to kind of adjust so that I get exactly that frequency so that I would have a more accurate measurement. Okay? Bottom row, I have a 3-position switch. If you look at your drawing, you'll notice it says AC, ground, and DC. First of all, when I ground this switch, what it does is it grounds the trace, and I can use that so that I can position as to where my 0-volt line is. So for example, if I move it down here, my 0-volt line is down here, and my trace will increase and decrease above and below that 0-volt line. Excuse me. Also, I can switch this to DC, and if there is any DC in this, not all changing signals like this are all alternating current. Some are shifted either all one polarity or mostly one polarity, either all positive or all negative or mostly positive, mostly negative. So there's a DC reference. By using that DC function, I can see that DC reference. It would actually shift my waveform either more positive or more negative depending on what that voltage is. All right, now the volt division knob. Now the volt division knob actually has two parts to it. Notice the top part of the knob right here. The top part of the knob, first thing is this knob will pull out. Notice it made my trace 5 times greater vertically, or it made it larger vertically, and it just so happens that it is 5 times greater. So that if I were to try and take a voltage measurement, of course I can't get it all on the screen there, but if I were to try and take a voltage measurement, whatever voltage I came up with would appear to be 5 times greater than it actually is. Understanding that, I would then divide by 5 and that would give me the correct voltage. Now, the purpose for that is if I have a really small signal, a really small voltage signal, I can amplify it 5 times and that would help make it larger for me to take a measurement. Then I would divide by 5 and come up with the correct voltage measurement. Okay? Now, this knob also has a feature where I can make an adjustment so that I can calibrate. If I know that I have a specific voltage on output and this isn't quite matching that, I can calibrate the scope to meet that voltage. Now, the actual volt division part of the knob is this part right here, the larger part of the knob, the side of the knob. You'll notice the indicator right here on the side, okay? Right now it's pointing to 2 volts, all right? We'll talk more about what the divisions mean, what that 2 volts means a little bit later. But this is my actual volt division. Now it sets the value for each square vertically. If I have it on 2 volts, that means each square vertically is worth 2 volts. The vertical mode switch to the right of the volt division knob tells me where, or actually, what I'm viewing. So right now it's on channel 1. I'm viewing the signal coming in on channel 1. If I switch this to channel 2, now I'm looking at what's on channel 2. Since I have nothing connected to channel 2, I have a flat line. I can also switch this to dual, and I can look at both channel 1 and channel 2. Now the benefit of that is to be able to analyze, say, an output compared to an input. Do I see a phase shift? All right, any way that I can compare the 2 signals together. I can also switch this to add, and what that would do is that would actually add the peak-to-peak voltages of the 2 signals on both channels 1 and 2 together. For example, if I had a 1 volt peak-to-peak channel on, signal on channel 1 and a 2 volt peak-to-peak signal on channel 2, it would add them together to display a 3 volt peak-to-peak signal on output. All right. The volt division knob for channel 2 does exactly the same thing as the volt division knob for channel 1, same with the 3-position switch for channel 2. And finally, the largest knob on the oscilloscope is the time division knob, and that sets the value for the squares side to side. All right, so that's the knobs, buttons, and switches for the oscilloscope. Okay, so now that we have kind of an idea of how all the knobs, buttons, and switches work, or rather what they do, the next thing we want to do is we want to be able to set up an oscilloscope. Now chances are, if you're actually using the oscilloscope, on the job or something, you've already got it set up to some degree. But what I've got here is I've got every knob, button, and switch just any which way. They're all messed up. So what I'm going to do is I'm going to go through and set the oscilloscope up to just a starting point. Set it up to a point where I can then say, okay, now I need to make some adjustments so that I can get the waveform in view and actually take a measurement. All right. So if you follow along in your drawing and if you want to take notes on this, I like to work systematically. And what I mean by that is I have a specific starting point. I work through one complete row, then I move to the next row, and then the last row. And I make sure that I put my hand on every knob, button, or switch on the oscilloscope. In other words, I don't just randomly start pushing buttons and flipping switches, because chances are, if I do that, I'm actually going to miss one. And it always happens. So, starting in the upper left-hand corner with the intensity knob, if you look at your drawing, it has the indicator pointing straight up and down, just like I've got right here. We're going to call that position centered. All right? So, the intensity knob is going to be centered. The next thing we're going to do is, if I'm working systematically, I'm working all across the top row. So now I'm going to take the focus knob and center it. Now there are two things that I'm going to do to the trigger level knob. And the first thing is that I'm going to make sure that it is pushed in. The next thing I'm going to do is make sure that it also is centered. The coupling switch will go to the upmost position to auto. The source switch also to the upmost position to channel 1. The hold off knob, I'm going to do two things to it, just like I did the trigger level knob. First thing is make sure that it's pushed in. Second thing is I'm going to center it. The XY button, I'm going to make sure that it's pushed out, in, out, in, out. Make sure that it's pushed out. The horizontal position knob, two things to it as well, pushed in and centered. Middle row, of course the power button, we're generally going to have that on, right? That would bring us to the vertical position knob for channel 1. Again, I'm going to do two things to the vertical position knob. Can you guess what those two things are? Yes, indeed. Pushed in and centered. Now, even though I'm not using channel 2, I'm going to set it up as though I am. So that means the vertical position knob, two things, pushed in and centered. Now, if you look at your variable sweep knob on the drawing, right, it shows that the variable sweep knob is centered. Folks, I cannot repeat this enough times. Do not center the variable sweep knob. You never center the variable sweep knob. Do not center the variable sweep knob. I'm telling you, I can't say it enough. Let me say it one more time. Do not center the variable sweep knob. So what do we do with it? Well, I'm glad y'all asked. Here's what I'm going to do with the variable sweep knob. I'm going to take and turn it clockwise all the way to the right so that the indicator actually points down toward the time division knob. All right? Remember, do not center the variable sweep knob. Next thing is, bottom row here, the 3-position switch for channel 1, the AC ground DC switch, we're going to switch that to the upmost position on channel, or on AC rather. Now, the volt division knob, there are actually 3 things that I'm going to do to this. The first thing is I'm going to make sure that the top part is pushed in. The second thing I'm going to do is make sure that the top part is locked into position all the way to the right, and you'll hear it when it locks into position. Okay? The next thing I'm going to do is the actual volt division part of the knob, which is this big part of the knob right here. I'm going to adjust that so that it's pointing at 0.2 volts right now. That way it's almost centered. The vertical mode switch goes to the upmost position to channel 1. The volt division knob for channel 2. Again, 3 things. Top part pushed in, locked into position all the way to the right, volt division set to 0.2 volts. The 3-position switch for channel 2, all the way up to AC, so that all 5 switches should be in the upmost position. The time division knob, I'm going to go ahead and just to have a place to start from, set it to 0.5 milliseconds. Now, if you take a look at the screen right here, perhaps all you see are some lines across it. Now that's good or bad depending on what we're working with here, but I can't take a measurement like that. All I see is just a green light almost. So that means I'm now going to have to make some further adjustments. But the good thing is, having done all of this, I'm down to just 2 knobs. And at this point, I'm going to start with the volt division knob. And what I'm going to do is I'm going to adjust the volt division knob one way or the other until I see both top and bottom of the trace. There we go. See, I see both top and bottom now. All right. Now that I have it set to this point, the next thing I'm going to do is adjust the time division. So once I get the volt division set where I can see both top and bottom of the trace, the next thing I'm going to do is use the time division knob. So I'm going to adjust one way or the other. Okay, well that doesn't seem to be helping very much, so we must need to go back the other way. So let's keep going here. There we go. Now we're starting to see something. So how do I know when to stop? All right, watch. What I'm going to do is I need at least 1 complete cycle on here, right? So I'm going to adjust until I get just too big and then come back 1. Now I can clearly see that I have at least 1 complete cycle. I have 1 positive half and 1 negative half. For 1 complete cycle, the trace will touch this center line 3 times. Once, twice, 3 times. Between points 1 and 3 is 1 complete cycle. So there we have it. Now from here, I can make some minor adjustments. I can tweak. I can focus the image. I can move it up or down as I need to. And what I'm going to do now is move this over so I can measure the volts peak to peak. All right, I got 1, 2, 3, 4.4 squares up and down. Volt division knob is set to 2 volts. 4.4 squares times 2 volts would be 8.8 volts peak to peak. Now then, for the period of the wave, remember we're going to count the number of squares for 1 complete cycle. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9 squares. My time division knob is set to 1 microsecond. So 9 squares times 1 microsecond, that would give me 9 microseconds. Then for the frequency, remember all I need to do is just simply hit the 1/x key. Once I do that, I have the frequency, which should be pretty close to about 109 kilohertz, 110 kilohertz, somewhere along in there, maybe 90, 99, something like that. All right, so there we are. There we have it. That's how you set the oscilloscope up and take your measurements.